Okay guys, this is your introduction to torque. Torque simply says torque, which is what we call like a funny T, it's called like gamma, is equal to the force cross into the level arm, which is D. That's just a funny way to say that these two guys need to be perpendicular to each other. So whenever you find the force, you want, like for instance, if you had a ruler or just an imaginary weight, pretend that line has no weight, this would be your force, has to be perpendicular, and then your level arm would be your distance from here to here. Very simple calculation. Two types of torque. You have what we call a counterclockwise torque and a clockwise torque. It just depends on which way this guy's going to rotate. For this particular example right here, that's going to produce a counterclockwise torque because it's going to rotate around the pivot point. You always want to ID your pivot point. Torque is always measured in Newton meters because force is in newtons, right? And distance is in meters. Another important thing you want to say, anytime you talk about uniform, like if you had a uniform yardstick, you always put the pivot point in the center because that's where all the math really acts at. So you got to watch that half space right there. With that in mind, let's go ahead and get a new canvas. Go to example number 1, which simply says, here we go. Let me clean this up a little bit so you can see what's going on. Move it over. There's the question right there. That is example number question, torque example question number 1. Let's go back over here and grab our handy dandy brush, which simply says, here's your picture. You have a yardstick, and since the word says uniform, you want to make sure you draw a point in the center. That's where the force is going to take place at. The pivot point is on the right. At the left hand. Sorry, misread that. The pivot point is actually on the left end. So let's undo that. Okay, the pivot point is actually right here on the left side. So I like to know that if that's where it's going to pivot, this thing's going to rotate which way? Clockwise. My force is F equals mg, which is telling me about F equals mg. Draw a line through that, which tells me my torque is going to be F. That's my force times my distance. You know your F is mg. You know your distance is going to be d. But the most important thing that you got to remember is that distance is acting at the center because it said uniform, which simply means instead of having a 1 meter stick, which it is, you want your distance to act at where? 0.5 meters. That's the mistake most people make. Next thing you got to watch now is, torque has to equal to mass, which is, I think the mass says 250 grams, which you automatically change to 250 kilograms, right? G is 9.8. When you're dealing with torque, leave it positive. Your distance is 0.5. Now you know that your answer is torque is equal to, I think I got 1.23. Let me check my handy dandy calculator real quick. Let's slide it into the picture. I'm going to go 0.25 times 9.8 times 0.5 because it's uniformed, hit equals, and that gives me 1.23 because we always round up. So my answer is 1.23. Units are going to be Newton meters, but you always got to give me a direction, in this case clockwise. That's example number 1, torque. Torque as a review, torque causes a rotation around the pivot point. Always identify the pivot point. Next thing you always want to do is, since it's uniform, it says that the arrow has to be where the force acting the center of it. And then you do your straight calculation. Make sure these guys are what? Perpendicular. If they're not perpendicular, then we know we're going to have to find the what? sine for this angle right here. That will come up in the lesson here in just a few seconds. Thanks.